Good morning, students. We will start firstly inorganic chemistry. In inorganic chemistry, there are two sections, section A and B, and syllabus is in section A, metal ligand bonding in transition metal complexes, and second chapter is thermodynamic and kinetic aspects of metal complexes. And in section B, there are two chapters. One is magnetic properties of transition metal complexes, and fourth chapter is electronic spectra of transition metal complexes. So all these are the four chapters in this semester, and in this we firstly discuss metal ligand bonding in transition metal complexes. In this first topic is limitations of valence bond theory. As you have discussed valence bond theory in second year class, then in this we only discuss limitations of valence bond theory. ਤੁਸੀਂ ਪਿੱਛੇ ਸੈਕੰਡ ਈਅਰ ਕਲਾਸ 'ਚ ਕਰਕੇ ਆਏ ਹੋ valence bond theory ਸਾਰੀ sp3 hybridization, sp2 sp3d sp3d2 hybridization, all hybridization and paramagnetic, diamagnetic, magnetic behavior of the complexes. And in this we will discuss crystal field theory, and firstly we will discuss limitations of valence bond theory. Valence bond theory has some limitations, and firstly it provides only qualitative explanation of the complexes. Qualitative, no quantitative explanation, as no energy. You have discussed only hybridization, sp3 sp2 sp, as these hybridization. Only qualitative explanation, no quantitative explanation, means no energy determination. So it provides only qualitative explanation for the complexes. Second point is it does not explain the color and electronic spectra of complexes. You only discuss in valence bond theory paramagnetic, diamagnetic character, and it does not explain any color, which complexes are in which color, and electronic spectra of complexes. And third point is this theory fails to explain which complexes will be high spin complexes and which will be low spin complexes. In high spin complexes there will be more number of unpaired electrons, and these will be outer orbital complexes, whereas some complexes which are low spin, it means there will be more pairing of the electrons and they will be inner orbital. For example, d2 sp3 dsp2, all these are inner orbital complexes and these are low spin complexes. Whereas high spin complexes, in this more number of unpaired electrons and there will be outer orbital complexes, for example sp3d2, all these are the high spin complexes. And next point is, so this theory fails to explain why some complexes in particular oxidation state are low spin complexes and while some complexes are high spin. For example, cobalt ammonia 6 3 positive, this complex is low spin and this form inner orbital complex, whereas cobalt f6 ligand and 3 negative, where this forms high spin complex, and this theory does not explain this. Next point is fourth, it does not explain relative stabilities of different complexes. As we discussed, there are new terms, labile and inert complexes. Labile complexes in which there is displacement of one ligand by the another ligand that takes place rapidly, that are labile complexes, whereas inert in which there is ligand displacement is very slow, it means there is displacement of one ligand by the another ligand that takes place very slowly or at negative और बिल्कुल ना के बराबर होगी, so that will be inert complexes. And so this theory does not explain the relative stability, why some are labile, why some are inert, and does not explain the kinetic inertness of the complexes. Fifth point is it does not explain the variation of magnetic moment values with temperature. As in second year class, valence bond theory explains the magnetic moment values, and that is equal to under root n into n plus 2, that is the magnetic moment calculation. And we also discussed that which complexes are paramagnetic, which are diamagnetic complexes, but it does not explain the variation of magnetic moment values with temperature. Next point is, it does not explain the splitting of d energy levels, and this we will discuss in the crystal field theory. And next point is, it does not explain the relative stabilities of different structures. And eighth point is, valence bond theory does not predict whether the four coordinate complexes will be square planar or tetrahedral, as nickel 2 in some complexes it will form sp3 hybridization, and in some it will form dsp2 hybridization. In sp3 outer orbitals participate, whereas in dsp2 the inner orbital d orbital participates. So while some four coordinate complexes are sp3 and dsp2 hybridization, sp3 they will form tetrahedral complexes, whereas dsp2 they will form square planar and there will be diamagnetic. So why four coordinated complexes, some will form tetrahedral or square planar, and this is not explained by the valence bond theory. Next is, the valence bond theory does not tell us why water and halide ions commonly form high spin complexes while cyanide ions form low spin complexes. As we have discussed कि water and halide ions, they are weak ligands. Why these form high spin complexes, and cyanide as we consider it as strong ligand, so why it will form low spin complexes, this is not explained by the valence bond theory. So all these are the limitations of the valence bond theory. Next is crystal field theory, that is very important and main topic in fifth semester, that is the crystal field theory, and that is developed by H. Beth and V. Black. So this is the crystal field theory. And crystal field theory assumptions are, as valence bond theory that considers the bonding between the metal ion and ligands as purely ionic, whereas जो मेटल लिगेंड बॉन्डिंग है इन मेटल एंड लिगेंड्स, that in according to the valence bond theory that is covalent, whereas the bonding between the metal and ligands according to the crystal field theory that is purely electrostatic. Electrostatic means ionic bonding. So valence bond theory की एक्सप्लेन करता है कि बॉन्डिंग बिटवीन मेटल एंड लीगेंड्स ਦੇ ਵਿੱਚ ਕਿਹੜੀ ਹੈ, ਕੋਵੈਲੈਂਟ ਬॉन्डिंग है, बट जो अपने को क्रिस्टल फील्ड थ्योरी है डैट एक्सप्लेन्स द बॉन्डिंग बिटवीन द मेटल एंड लीगेंड्स, डैट इज आयनिक बॉन्डिंग और प्योरली इलेक्ट्रोस्टैटिक बॉन्डिंग. So this is the main assumption of crystal field theory, is that metal ion and ligands act as point charges and interaction between them are purely electrostatic or 100% ionic characters. So there in ionic bonding there will be point charges, and there one will be the positive charge, other will be the negative charge, and there will be ion-ion interactions. If we take ligands as negative charge ligand, then interactions will be ion-ion interactions. Whereas if ligands are neutral molecules, for example ammonia, water, so in this there will be dipole creation. For example ammonia, in ammonia nitrogen is more electronegative as compared to hydrogen, so it will require delta negative, hydrogen will require delta positive charge, so there will be dipole creation. And similarly in water, oxygen is more electronegative, delta negative, hydrogen requires delta positive. So metal that is having delta positive charge, that is interacted with the negative charge of the ligand, part of the ligand on the nitrogen atom, and positive charges on the hydrogen atom. So there will be interaction that will be ion dipole interaction. So there will be two types of interactions, one will be ion-ion interactions and other will be ion dipole interactions. For example in case of cobalt F negative complexes, so cobalt positive and F negative, so interaction will be ion-ion interactions. Whereas in case of cobalt ammonia complex, so this will be the ion dipole interaction, because cobalt is having delta positive and ammonia nitrogen acquires delta negative charge. So this is the main assumption of crystal field theory. Then metal ion that is surrounded by the spherical field of the ligands and that is affected by the ligand surrounding. So within the lattice of crystal that is affected by the non-spherical electric field established by the ions or molecules, and that is called crystal field, and this is the crystal field theory that we'll discuss later. Firstly, main basis of crystal field theory. First basis, that is the transition metal ion, center च metal ion होएगा, and that is surrounded by the ligands that is having lone pair of electrons. Second point, there all types of ligands act as point charges, and there will be two types of interactions. One will be ion-ion interactions and the second will be ion dipole interactions. So this is the purely electrostatic, that is the 100% ionic character. Fourth point is, firstly there will be ligands that surrounding the metal ion that produce electric field, and that this electric field influences the energy of the d orbitals or energy of the orbitals of central metal ion. And fifth point is, now we will discuss main basis of crystal field theory, that firstly free metal ion, we take free metal ion. In free metal ion there will be d orbitals, and we know that there are all 5 degenerate orbitals. 5 degenerate means having same energy. In case of free metal ion there will be 5 degenerate free ion, and these are the 5 degenerate orbitals. They are at the same level, and an electron can occupy any of the 5 d orbitals. So these are called degenerate, means having same energy, all are of same energy. Electron can occupy in any of these 5 d orbitals. Now we take ligands that surrounds the central metal ion as we form complex. So central metal ion that will surround the ligands that will surround the central metal ion, and we consider firstly all the ligands are approaching the central metal ion equally at the same distance. Then they will form spherical electric field around the central metal ion. Then there will be repulsion between the metal having d orbitals and having electrons, and ligands that is having lone pair of electrons. So similar charges always repel. So किदे which repulsion होएगी, metal ion है, metal ion that is having d orbitals and having electrons, and in case of ligand, that is metal ion is surrounded by ligands and ligands also having electrons. So there will be repulsion between the electrons. So firstly appa ki likhta hai, free metal ion, all 5 degenerate orbitals, and then all the ligands are approaching the central metal ion equal distance. They will form spherical electric field, and there will be repulsion between the ligand electrons या lone pair of electrons between the central metal ion d orbital electrons. So there will be repulsion between them. Then due to repulsion the energy of d orbitals that increases, but still they are degenerate orbitals, means सब दी energy की होएगी equal level पे increase होएगा, because there are 5 degenerate orbitals. Then they are having, but they are still having higher energy than the free metal ion. So this is the case in which they are having high energy as compared to free metal ion, but still they are degenerate, means having same energy but higher than the free metal ion. Next is, as d orbitals are having different shapes, d orbitals are having different shapes, 5 d orbitals dxy, dyz, dzx, and 2 orbitals dx square minus y square and dz square. 3 orbitals dxy, yz and dzx. In these, lobes are in between the principal axis. between dxy means lobes between the x and y axis, yz means lobes between the y and z axis, and in dzx lobes between the z and x axis. Whereas in case of dx square minus y square and dz square, lobes will be along the principal axis. So the ligands which are approaching the approaching the same direction of the orbitals, या आपा की कहेंगे the ligands orbitals lying which are in the same position of the ligands, orbitals that is lying towards the direction of the ligands. देखो ना एक्स एक्सिस है, अगर ਜਿਹੜੇ ਲੀਗੈਂड्स ਕੀ ਹੋਣਗੇ ਅਲੋਂਗ ਦੀ ਲੋਬਸ ਜਿਨ੍ਹਾਂ 'ਚ ਇਲੈਕਟ੍ਰੋਨਸ ਹੋਣਗੇ ਉਸ ਐਕਸਿਸ ਦੇ ਅਰਾਊਂਡ ਹੋਣਗੇ, ਦੈਨ ਕੀ ਹੋਏਗਾ, ਡੈਟ ਵਿਲ be more repulsion, and which are away from those direction that will be less repulsion. So which are having more repulsion ਜਿਹੜੇ approach ਕਰਨਗੇ on in the direction of the ligands, the lobes that is along the direction of the ligands that will repel greater than the lobes which are in between the axis that will repel less. So there will be more repulsion and more energy increase, and there will be less repulsion means there will be less increase in energy. देखो ना ऊपर लिखा हुआ है इन्होंने कि अपने कोले लिखा है कि d orbitals are having different orientations and orbitals will experience different interactions. So from the ligands, the orbitals lying in the direction of the ligands will experience greater repulsion. ਜਿਹੜੀ orbital ਬਿਲਕੁਲ ligands ਦੀ direction 'ਚ ਪਈਆਂ ਹੋਣਗੀਆਂ ਉਹਨਾਂ 'ਚ ਕੀ ਹੋਏਗੀ, ਜ਼ਿਆਦਾ repulsion ਹੋਣਗੀਆਂ, ਔਰ ਜਿਹੜੀਆਂ orbitals away from the direction of ligands ਹੋਣਗੀਆਂ ਉਹ ਕੀ ਹੋਣਗੀਆਂ, ਆਪਣੇ ਕੋਲੇ less repulsion ਹੋਏਗੀ, ਉਹਨਾਂ ਦੀ energy ਕੀ ਹੋਏਗੀ, less ਹੋਏਗੀ. So there will be splitting of d orbitals into two sets, and this is the crystal field splitting. The conversion of 5, so ਇੱਥੇ ਦੇਖੋ ਆ ਲਿਖਿਆ 2 set ਬਣ ਗਏ ਆਪਣੇ ਕੋਲ, 3 will be down and 2 will be above, having higher energy, and 3 will be having lower energy. So this will be the crystal field splitting of d orbitals. So this will explain tomorrow, and today is only basis of crystal field theory. So the conversion of 5 degenerate d orbitals of metal ion into different set of orbitals having different energies in the presence of electric field of ligands. So this will be crystal field splitting will be different in different structures and different coordination number, magnetic properties भी different होंगी. So these are the shapes of d orbitals, and this is the crystal field splitting into 2 sets of d orbitals. So this is the main basis of crystal field theory. Thank you students.